I kindly invite Professor Janko Bozic from Slovenia to share his screen and to present us. But before that, just a few words about Janko. He's a very famous professor on bee biology. He has participated to many events, to many Apimondia events and some other events. We have co-organized, like recently, a big conference on AP pediatry for the children. And he's a very good friend of ours and has a deep knowledge on bee biology. And it was this big question to solve, and he will be able to help us. How is the bee body, the bee physiology, and the bee biology, if you want, help the beehive air creation and uses? Please, Janko, the floor is yours.
Thank you, Stefan, for the introduction. Yeah, this is really very interesting topic, and I will try to make kind of a review of potential role of the bees and how we are working on. And yeah, we should say that bee air is a result of bee activity on some way. Now is the question, how much is that related to the release of chemicals from a bee body, and how much is that related to the bee products? Can you see the whole screen now?
No, not yet, not yet. If you can press on that button to make it full screen.
Yeah, I press full screen, so I'm just asking if you can see full screen.
Not yet. So what you can do, Janko,
okay.
You can stop the share screen.
Yeah.
Okay, and then when you press again on the share screen, do not go directly to the PowerPoint.
Just whole screen, huh?
Share screen and then give OK, and give OK on the right.
Okay, the bottom. And yes. Then I will do this.
Yes, yes, and now press on that.
Now you see full screen?
Yes, perfect. Now, perfect.
Okay, cool.
Okay.
Okay, that's my starting. Okay. Yeah, so that's I would try to have some kind of review of these different effects, and definitely we could divide somehow on that real contribution of the bees, and another part related to the bee activities, how they are working in the hive and how that can be contributed. So one of the potential sources are volatile pheromones that are released during communication of the bees. We know very well of them. On the other hand, also in nature it's typical that pheromones work at very low concentration. So only few pheromones are existing at higher concentrations, and we can smell them in such cases. So if we will go in worker bees, what beekeeper is most often capable to smell are two things. One is so-called nasano pheromone, which is typically released in front of the hive with some bees before entering the hive, or sometimes during the swarming is a huge release because bees are attracting the other bees into the cluster. And also during foraging, bees are attracting new foragers, new bees, which are maybe for the first time, they could be a little bit less well-oriented into the hive. So that at that time could be bigger release of nasano pheromone. And this pheromone, as you might know, has very similar smell as Melissa plant. So it contains the same etheric oils like geraniol, citral, and nerol. So that's why also beekeepers sometimes using Melissa plant in some beekeeping practices. And another thing which is also very often recognized by beekeeper and others when bees are stinging, they are releasing also alarm pheromone. And one of the main component, which is smelly, is isopentyl acetate. So, and there are also some other esters, so some aliphatic substances, very at this point more rare aromatic. So aromatic might be at other parts. So these are usually chemicals that we can really smell, but with the regular Hive aromatherapy, we could expect we can get a little bit of that nasonal pheromone at the back, but typically that is pushed out of the hive, not inside of the hive. So that type of the smell is not much released in the hive. But when our bees managing different kinds of material in the hive, they could release some other volatiles. For example, when they're diluting propolis, managing wax, but we will talk about that also later, they release one compound, which is sometimes supposed also part of alarm pheromone released from the mouth parts, from the mandibular gland, heptanone. So it's ketone, which is very smelly, like some kind of cheese, and the same smell. And yeah, that can be part of the smell of the hive if bees are very active. They also release these the attack of the wax mouth larvae and so on. So recently it has been recognized also some foraging pheromones, or pheromones which are related to the foragers. So forager bees are releasing ethyl oleate. That's an ester of oleic acid and ethyl, and that is also present, and there are some other aliphatic esters present, but usually those aliphatic esters are not very volatile, but they could be released a little bit in the air, and that's one possibility which could be part. So when we check when some chemists are checking the air, they could be maybe more focused also on this type of compounds and potential source of the from the bees, like these simple esters of fatty acids. Yeah, queen is important for the bees. She's controlling the bees through chemical communication, through release of pheromones, but a lot of those pheromones has to be directly collected from a queen bee. But some are also little volatile, some aromatic type from the mandibular gland, like homovanillic acid and para-hydroxybenzoic acid, but those are really in minor amounts. So I would say it would be most likely very hard to find in the air. So it's very low concentration, as well some esters from the tertiary gland from the abdomen, which are released continuously from the queen bee. But more important is that those pheromones are affecting bee activity, and if queen is producing more pheromones, bees are more active and do more foraging and so on. So this is then more indirect contribution of the queen. So direct is very low. So maybe a bit more, but I'm not sure if that has been recognized. Maybe you will hear that in some lectures later. Brood is releasing also brood pheromone. There are also some esters of fatty acids, and one very important is also more close to the typical essential oils, which is beta-ocimene, very small molecule, and that one is released I think by young larvae, that is then activating bees to do more foraging, and also is helping for the larvae to be fed by the worker bees. So a lot of brood could partially contribute. It's not something typical that we would recognize by our smell, like it's the sonopheromone or the alarm pheromone, but could be part of general bouquet of the hive air. Okay, then we have another part which is more directly connected to the beehive air, and that part is bees activity, how bees are contributing with their activity. And of course, there are different types. It's not just moving around and releasing their pheromones, but it's more how they're managing the whole hive and how they are collecting things that are needed for the hive, so food resources and raisins for propolis. So all that is very important. So we go one by one. So when they're starting preparing the whole cavity, usually when swarm is occupying the area, would start building the comb and releasing wax scales, and combine that also with excretions of the glands in the head, and all this contributing to the structure of the comb. But inside of this fresh wax are also some volatile compounds which can be recognized. Some could be some smaller esters and so on. And because of the nature of the substances, it can bind some lipophilic compounds which are also volatile and can be later slowly released. So wax matrix is very important because it can absorb some of the volatiles which are hydrophobic and then released slowly in the air. So that's comb building is one process, and also that during that process we can get some extra smell, and we of course the whole comb with the aging is getting smell which is more related with the feeling of the comb with the honey and bee bread, and also breeding brood inside. So foraging activity is definitely one of the major contributors. Some are saying the most important contributor to the hive air. So we have to pay attention to that part. And if there is more or less monofloral type of forage, that there exists a huge area of one type of melliferous plant that is then preferred by the bees, then this hive air could have very strong effect just by one plant. From experience, you know that exists like from black locust flowering and chestnut flowering, where is a lot of linden, also linden flowering, and maybe some crops like here buckwheat, and they have specific volatiles which are then also released during this honey processing. So we can go with that a little bit further. So that's most likely one of the most important way how to get different bouquet in that hive air. That bees are collecting honey, and if they're more diverse forage, they would have more diverse also honey stores, and also more diverse bee bread. Along with the bee bread, there is some processing and release of some volatiles related with that process. But in general, most of those volatiles are derived from the plants. So this part of bee activity inside of the hive, managing of the honey stores and processing of the honey stores is releasing smells which are mainly derived from the plants. Okay, but that's also stored when bees are using it, can be released some more after opening the cell and so on. The next thing is propolis, so propolization of the surfaces of the hive. This is a specific and in honeybees, and it's typical for Apis mellifera that is collecting propolis and using that kind of social defense system against microbes in the hive. And usually there is a thin film on the surfaces of the hive, also on the margins of the comb. And if it's old comb, sometimes they try to make it better with a little of propolization that is not so affected by mold or something else. And also something sometimes happens that they have some kind of intruders that they cannot remove out of the hive, and they would propolize them completely. So during this processing, also bees are using secretions of the glands. That maybe this part was overlooked a little bit, that actually manipulation of the propolis and bee resin is only possible if bees have diluent. And again, one of that potential compound for dilution could be heptanone. As far as I know, in some fresh propolis, they have detected heptanone as a part of propolis. Of course, when the propolis is old, heptanone is already not present because evaporation is quite fast, but in fresh preparing of the propolis, more compound is present. And we know that heptanone is also potential use, is also like a narcotic. So, but of course, in hive air would not be in such huge amount that we will get slip over, like bees are making wax larvae to be immobile and that they can take it out. So that is one reason why they use that, like to attack this wax mouth larvae, to take it out, to immobilize it, and it's not moving anymore, and it's easier to take it out. But it's also diluent for the bee raisins, and when they do a lot of replacement of the propolis, you know, bees are can get pieces of propolis one side of the hive and put another where is needed. So, but for the production, we can increase using mesh, and then bees are collecting more, and we have, I would say, bigger buffer of propolis compounds, and that some volatiles can be later released slowly if this propolis is not too old in the hive air. So that's one thing which can be improved a lot to stimulate bees to do more propolization. And another effect which might be more typical for Slovenia is when we put a lot of hives in one big house. We used to do that with our type of the hive, Age hive. So we could have three rows of the hives, and big house was always built in that way. And usually during the summer, hives at the back are open. They have mesh windows inside, and the whole bee house is full of the hive air. We used to do that. We have not explored a lot of these possibilities in the past, but some beekeepers did, and now it's more and more beekeepers that are also taking advantage of that their bee houses could be a good places for kind of special aromatherapy related to the beehive. So that's quite a little bit different than just a few hives, you know, that you are using. So and the approach is a bit different, but maybe there can be done some discussion related to this approach using bigger bee houses with a lot of hives and much bigger amount of the air. I didn't have intention to go more in detail of our experience. You might hear that from some others, and but just to make some short review of the activities of the bees related to the hive air, as we heard. So it's very important what kind of plants do we have around, and that's then the main source of the hive air. Okay. Thank you for now. I'm ready maybe to help you in the discussion to get some view on this topic, and maybe some questions. I tried to search literature. It's amazing that this hive air is now quite popular for a long time, but hard to get a lot of peer-reviewed papers that are dealing with the hive air. So sometimes a problem to get enough methods to have recognized all the possible compounds, because this is a really complex matrix, and we have more data about the volatile compounds of the bee products. That are quite a lot of data, but not so much a lot of data in different circumstances about the actual compounds of hive air.